a given figure, a weightless pulley which is marked over here, weightless pulley is attached on double inclined frictionless surface. The tension of the string is okay. See, so what I'm going to do is, since both of the angles are different, 60 degree and 30 degree, and since the inclination on both sides are also different, what we'll do is we will try to understand this complete question by dividing this into two different halves. Okay. Give me a second. I'll just make the things more clear. So first half we will learn. Oh, oops, bad. My bad. Sorry. So what I was trying to say is we will divide this figure into two like this, and we'll discuss part 1 and part 2 separately in detail. Okay. But before we go into part 1, what we need to understand here is the very concept of resolution of weight on an inclined surface. So see, this is the inclined surface what we got here, right? So I'll write it down here. Resolution of weight on an inclined surface, resolution of weight on an inclined surface. So if a block is kept on a inclined surface like this, which is inclined at an angle theta, then this yellow line here represents the weight, the vector, right, mg. Now since the object is in contact with the surface, we know that whatever weight is being transferred to the surface, the surface will counteract it by giving in reaction to the body, which what we call is as normal reaction on the block due to the surface. Okay. Now, since this weight is also inclined, we can safely assume that the weight will have two components, one which is along this inclination horizontally and the other which is perpendicular to this inclination, which we will mark it as now. Now see, if we have to explain resolution one more time, things will become, it's going to be time consuming every time, every question, which becomes really difficult. Anyway, I'll just give you a glimpse of it. So see, we have, this is the weight, right, and we can resolve it like this: one component moving out, the other component also moves out, right, and all three will have the common point. And then how can you draw the triangle? You can draw the triangle like this by you can take this vector, right, and you can move it and you can keep it like this, right, and then you have the complete triangle. Or what you can do is you can complete the triangle like this also. You can move this vector, and keep it over here. Okay, that is what I have done in this figure. So we know that if this is theta, then the angle inside this triangle will also be equal to theta, right? Now, what is this yellow line? It represents mg. What is the perpendicular line? Since it's perpendicular, it's the vertical component wy, and this represents the horizontal component, that is wx. Now from this triangle, what is sine theta? Sine theta is opposite by hypotenuse, which is wx by mg. Therefore, wx is equal to, which is this inclining component, horizontal component, is actually equal to mg sine theta. What is cos theta from here? Cos theta is wy by hypotenuse, which is mg, wy by mg. Therefore, what is wy? Wy is mg cos theta, right? So this force, this weight can be divided into two different components, one mg sine theta and the other mg cos theta. So instead of 1 mg, I have written here 1 mg like this, mg sine theta, horizontal component, and then the other one mg cos theta, which is the vertical component. Now, which other forces are acting on the block here? See, this block is being tied by a rope. Therefore, how will the tension, direction of tension be marked? It will be marked away from the point of contact, right? And what is the net direction of motion? The net direction of motion here is towards, the net direction of motion is towards downwards. So we can say that all forces which are acting along the net direction of motion, that can be taken as positive. all forces which are acting along the direction of motion can be taken as positive. All which are acting against should be taken as negative. So when I write sigma f is equal to m into ax, then I can write that sigma fx, which is mg sine theta plus mg sine theta minus t, is equal to m into a. Okay, now what is t from here? T is equal to minus ma plus mg sine theta. Well, this is not relevant according to this question here, but still, if you write the sigma fy is equal to 0, why it is fy is equal to 0? Because there is no motion in the vertical direction. No motion in the there is no motion in the vertical direction. If there is no motion in the vertical direction, it means displacement is equal to 0, change in displacement is 0, which means velocity is 0, which means change in velocity is also equal to 0, and therefore acceleration is equal to 0, and therefore sigma fy is equal to m into ay is equal to 0. In which case we can say that the normal reaction and weight are, the vertical component of the weight are the only two forces acting on it, and a normal reaction on the 4 kilo mass due to the surface will be equal to mg cos theta. Okay, I hope this much is clear. See, now we are not yet entered the problem. And now we will move into the first step of the question, first part of the question. Okay, wait. Oh, I think we just explained it, right? Okay. In which case we'll have to substitute these values and understand the point here. Okay, so according to the question, what are the values here? Mass is given to us as 4. Theta is given to us as, the first angle is given to us as 60 degrees. So we can write here the first equation as t is equal to m into a, which is 4 into a plus m is 4, g is 10, 40 into sine 60. Okay, so this is the first equation. Right. Now let us move on to the second half of the diagram. And what happens second half of the diagram? Second half of the diagram, the inclination is towards the right. So the object will have a tendency to, this is the 4 kilogram body, this is the 1 kilogram body. So 4 kilogram body will come down and 1 kilogram body will go up, which means the net direction of motion here will be upwards. Anyway, before moving into that, let us try to understand the resolution of weight here one more time. So now I'm not going to explain much detail because we already have done it. So weight is acting downwards, right? Weight acting downwards. This angle is also theta. Weight can resolve into two components: one vertical, horizontal. Vertical is wy, horizontal is wx. W, if you take sine theta, you get wx by mg. Therefore, what is wx? Wx is equal to mg sine theta. Similarly, what is cos theta? Wy by mg. What is wy? That will be equal to mg cos theta. And after getting these two, what can we draw? We can draw the free body diagram. And in the free body diagram, we know that the net direction of motion is upwards. Why? Because the 1 kilogram body, the 3 kilogram body will pull this body towards it. So the net direction of motion is upwards. All the forces acting along the net direction of motion, which is upwards, are taken as positive. So here t will be plus t and mg sin theta will be minus mg sin theta. So we can say that minus mg sin theta plus t is equal to ma. Therefore, t is equal to ma plus mg sin theta, which brings us to the next equation, which is t is equal to ma plus mg sin theta. Here the mass is 1 kilogram. So this becomes 1 into a, which is a, plus m into g, which is 10 into, 1 into 10, which is 10, plus sine 30. Now we have two equations, right? Now we have two equations, and now both of them can be solved. So what is t is equal to? Okay, maybe I can write down the second equation over here. So what is t is equal to? T is equal to a plus 10 sine 30, right? And if you multiply this becomes 4t is equal to 4a plus 4 into 10 sine 30. And if you add these two, now what is 4t plus t? It is 5t. So 5t is equal to 4a minus 4 is 0, plus 4 into 10 is 40, and 40 plus 40 is 80. So, oh, sorry, my bad. It could be, so 40 sine 60, I can take 40 common into sine 60 plus sine 30. So this is 5t is equal to 40 into, what is sine 60? Sine 60 is root 3 by 2. What is sine 30? Sine 30 is 1 by 2. Therefore, what is tension? T is equal to, T will be equal to 5, 8. 8 by 2 is 4. 4 into root 3 plus 1.